Hello, welcome to this video. I've got this absolutely fabulous circle geometry question. It has to be one of my favourites. It wants us to find that measurement there, x. Okay, let's dive straight in. So what I've done is I've rotated the initial quarter of a circle that we had. We know it's a quarter of a circle because we've got the square there that says it's 90 degrees of right angle. And then I've added on this extra quarter of a circle there, meaning we can confidently say we've got a semicircle. And with that knowledge, what I'm hoping that I can find is that this is 90 degrees. And if it is 90 degrees, then I can join those lines up and work out this length using Pythagoras theorem. But let's see if it is a right angle, or you'll call it right triangle if you're in the States. So for it to be a right angle triangle, this line has to join there. Perfect, it does. And now we've got the circle theorem, which is Thales, which states that any triangle subtended from the diameter, so subtended just made, will be a right angle at any point on the circle. So that's our triangle, but it could be there to there. That would be a right angle. Now I'm going to go ahead and work out this measurement here because I can use Pythagoras theorem, otherwise known as Pythagorean theorem, and that's a squared plus b squared equals c squared. In an exam, make sure you write the theorem out. There could be a mark, a credit for it. And go ahead and label your triangle. That one's A. That can be B. This, the hypotenuse, longest side is always C. Let's put our numbers in. We got 3 squared plus 4 squared equals C squared. Now this is one of Pythagoras's triangles, so C should be 5, but we're going to go ahead and prove it still. 3 squared is 9 plus 16 equals C squared. So 25 equals C squared. We'll take the square root of both sides. I always write my operations on the side. Examiners like to see what you've done. Again, you could get a mark for that, but it also means when you're going back over, you can, double check you're working out. And so C equals 5. You can pop that on the triangle. And from there, we can now see that that length is the same as that length. So we've got an isosceles. That one's 5 centimetres. And so that means that this long length here is 5 plus 3, which is 8. And now we've got that length and we have this length. Well, we can go ahead and work out what this is. This is the diameter of our circle. So if we put those numbers in, we've got 4 for this length and 8 for that length. And again, that one will be our hypotenuse. So we got 4 squared plus the 8 squared. That's 4 squared there, that 8 squared there equals d squared. That's 16 plus 64 equals d squared. 80 equals d squared. And square root of 80, d equals 4 root 5. And then lastly, we need this measurement here, and I'm going to call that the radius and call that r. And so over here, r equals a half of d, which equals 4 root 5 over 2, giving us 2 root 5. And with that, we can go ahead and work out this triangle here, which is the one we wanted. We have x there. We can say that x squared plus 2 root 5 squared will equal 5 squared. X squared equals 5 squared minus 2 root 5 squared. X squared equals 5. What we wanted was x, so x equals root 5. And there it is. I hope you enjoyed that. Thank you so much for watching and look forward to seeing you next time. Bye bye.